Okay, so we just graphed piecewise functions and now we're going to graph absolute value functions. So just to warm up, we're going to actually do the long way to figure out what does this graph actually look like. And then we're going to learn what are called shortcuts using transformations. So absolute value, remember, when you plug a number in, is always positive. So I'm going to pick a couple of negatives. 0, we always like to try, and then just a couple of positives, and they don't have to be huge. So if I take the absolute value of -2, I'm going to get +2. Absolute value of -1, 0 stays 0, and then any number that you put in that's positive, it still stays positive, so you don't make it the opposite number. Okay, so we're going to go ahead and plot these. So -2 up 2, -1, 1, 0, 0, 1, 1, 2, 2, and then if we would keep going, we would end up getting all the numbers, and they're always going to be positive, so your graph's always going to be above the x-axis. And it's going to end up making this V shape. Try to draw this. I'm using a tablet, so it's hard to make it straight. So that is the shape of an absolute value. And then what happens is we put in a bunch of numbers, which are called transformations, and we move them up, down, left, right, and we flip them. So absolute value of a number is its distance from 0 or the origin. The shape of an absolute value is a V shape, and it's going to point up or down. So a parent graph is what we call this. So since we don't have any numbers or any shifts and it starts at the origin, this is called the parent graph, okay? So that's what we start out with. And this can work for quadratics or any shape, really. The point of the absolute value is called the vertex. So that's the mathematical term, and I'll be using that from now on. So to find the vertex form, I'm going to write it like this. Y equals, and I'm going to put plus or minus an A number, H, X plus or minus H, plus or minus K. Okay? And we can use B and C, but we just use H and K specifically for absolute value. So there are some transformations. So we're going to memorize this because these are like your shortcuts. So we don't really want to make a table because that takes a lot of time. So once you learn these transformations, we'll use it for quadratics, cubics, quartics, everything else coming up, trig, in your future math courses. So it's really beneficial if you learn these transformations now. So if you have a negative in front, so if it's a positive, it stays the same orientation. And so I'll just put the V. If it's a negative, it is an x-axis reflection. And so it's going to be upside down. Okay? The A number, it's kind of like your slope. So I'm going to put this in kind of quotes. It's not really slope, but since these are lines, two different lines, we can kind of think of that as slope. Now, inside the parenthesis, we call this H, and the key to H, this is always the hardest, is it's the opposite direction, left and right. So if you see a negative, well, negatives usually go to the left, so it's actually going to move it to the right. And if you see a positive, positives go to the right, so the opposite, it actually moves left. The number at the end is called a vertical shift up and down, and it's the same. So if you see a plus, it moves it up. And if you see a minus, it moves it down, okay? So once we know the basic shape, we really can use these transformation rules to make graphing super quick, okay? So first, let's just work on identifying these transformations. So example number 1, the quantity x minus 2 plus 5. So I don't have any number front, so I know it's not going to flip or there's not going to be a stretch. So I'm just going to write none. So let's look at the orientation. Inside we have a minus 2. So remember, minuses usually go to the left, so we're going to go right 2. All right, and then the number at the end, that's the same. It says it's plus, we're going to go up 5. And so that actually becomes our vertex. So we went to the right 2 and we went up 5. And then we could graph that. All right. Notice on the original graph, the slope is like 1. So we went to the right 1, up 1, right 1, up 1. All right. Let's look at our second example. There's no number in front, so we don't have a stretch or a flip. There's no number inside, so we're not going to go left or right. So that means our x value is actually 0. And then this -3 is outside the parenthesis, the absolute value, so we're going to go down 3 units. And so this will be -3. Okay, so see how I say down 3, but when I go to the vertex, I write -3 because that's down. All right, this one, we have a 2 in front, so that means we would go to the right 2. Oops, sorry. It's going to be twice as steep. So we're going to go to the right 1 and we're going to go up 2. So it's not quite the same. It is slope. And then we'll do that in both directions. So we would go left 1 and up 2 as well. Okay, so we're going to say stretch of 2. There is no flip. The number inside is the opposite. So positives usually go to the right. So we're going to go to the left 1. So that means -1. And then there's no number at the end, so we don't go up or down. So we still stay at 0. Okay, is this making sense? And then the last one I tried to make the hardest. So this is unusual because when you do transformations, you have to think negative and 3 as two different things. So the negative is going to flip it, so it's going to look like an upside down V. And the 3 stretches it 3 times as tall. So this has both 3 and a flip. The opposite positive, so this would be to the left 6, so -6. And then the 2 is up and down the same, so we're going to go up 2, so +2. Okay, so once you can identify the transformation, then it's actually really quick to graph. So let's look at number 1. Now we want to graph them. So I'm going to graph my vertex at 2, 5. So 1, 2, 1, 2, 3, 4, 5. And then this one didn't have a stretch or a flip, so we're just going to go to the right 1, up 1, and to the left 1, up 1. And that's your, typical. Make that go through the dot. Sorry, I have a tablet, so it makes it harder. Okay. All right, let's look at example 2. Our vertex was 0, -3. 1, 2, 3. We don't flip it. We don't stretch it. And we've already moved our vertex. So now we just go to the right 1, up 1, to the left 1, up 1. And if you want a couple more dots to help, you certainly can. We just follow that pattern. And then you just draw a couple. All right, so now we're going to do some stretching. So we've got -1, 0 is our vertex. And so now we want to stretch it. So I'm going to go to the right 1, but I'm going to go up 2, so that slope is twice as tall, and go left and up 2. And if you want another dot, you can. Go to the right 1, up 2, left 1, up 2. And you can do how many that you feel comfortable with. 1 is enough, but 2 just helps me, especially with the tablet, make that look nice. The last one has the most changes. So we're at -6, 2, 1, 2, 3, 4, 5, 6, and then up 2. So this one, you have to remember that we are going to flip it. So we're going to go to the right 1, but instead of going up 3, we go down 3. 1, 2, 3. And same thing over here. And we could do it again. This one's off, but that's okay. We won't always be able to stay on the grid because these are just general grids. All right, so make sure you watch your signs and do the right transformation rule. All right, good luck.